Hello, dear students. I welcome you all for the online lecture series of Design of Concrete Structure. In today's lecture, we are going to see the design of two-way slab. Our first step to design the two-way slab is to calculate the ratio of Ly by Lx. If this ratio is less than 2, that time we go for the design of a slab, that is it is a two-way slab. That is the slab is designed as an two-way slab. Okay. Then the second step is to calculate the design parameter. Now which design parameter we have to calculate is Ku max, Pt max and Ru max. I have mentioned the table. In this table you will be getting directly the values. For example, in this table, suppose my concrete is of grade M25 and steel is of grade Fe500. That time my value of Ku max will be 4.6, Pt max will be 0.95 and Ru max is 3.34. Got it? Okay. Now my next step is to assume the suitable depth. We assume that Pt is less than Pt max. Okay. Then we have the formula for it, that small d is equals to L upon L by d basic into alpha 1. Now if Lx is less than 3.5 and Ll, that is Ly, is less than 3. Live load is less than 3 kN per meter square, we use figure number 5. And if Lx is greater than 3 and Ll is also greater than 3, that time we use figure number 4. Okay. That then for a cantilever slab, L by d basic is 7. For a simply supported slab it is 20, and for continuous slab it is 26. And alpha 1 is the modification factor. If we refer to the figure number 4 of IS 456-2000, which is available on page number 38. The next we have to calculate for calculation of alpha 1, we need to calculate the Fs first. Fs is equals to 0.58 into Fy into AST required divided by AST provided. Now what we do here, we assume that our AST required is equals to AST provided. Okay, that is AST required upon AST provided is 1. And by substituting the value of F in all this value into Fs, we plot the diagram for calculate the value of alpha 1. Then we calculate the overall depth. Small d is equals to d plus dc dash. Dc dash is equals to d plus F by 2. For dc, that is the depth of the cover, refer the page number 47 of table number 16, and F is nothing but the diameter of the bar. Then what we do is we calculate the effective span. Effective span is equals to Lex is equals to Lx plus d or Lx plus Ls, whichever is less. If you refer our page number 34 and 35, you will be getting this formula also over there. Or Ley is equals to Ly plus d or Ly plus Ls, whichever is less. less. Okay, then we go for the dead load calculation. The first load which is acting on the slab is the dead load, or we also call it as self weight of the slab. The self weight of the slab is nothing but the 25 into D. Then comes the floor finish load. It is equals to 1 kilonewton for the floor slab and 1.5 to 2.5 kilonewton per meter square for the roof slab. Now after this we calculate the live load. If it is not mentioned in the statement, we have to assume it. So how to assume it? First, for the residential building. For residential building it is 2 to 2.5 kilonewton per meter square. Then for the public building we are assuming it as 2.5 to 4 kilonewton per meter square for the public building. Then what we do over here is we take summation of dead load plus floor finish load plus live load, and that total load is denoted by the capital letter W. Then we assume the unit width of a strip of a slab. Why do we assume it as a unit width? Because we want the total, we multiply it by the unit width for the slab. That's why for calculation of W we multiply WU is equals to 1.5 into W into 1. Hence whatever the load will be which will be acting on the slab will be in the form of kilonewton per meter. 1.5 into W into kilonewton per meter. Okay, now after calculation of the W, what we need is we need the calculation of the bending moment. Now if you consider the bending moment in the case of one-way slab and again in the case of two-way slab, there is difference in the calculation of an bending moment. How to calculate the bending moment in MUX and MUY direction? It is done from table number 26 on page number 91 and page number 90. Okay, for the shorter span, MUX is equals to AX into WU into LEX, and MUY is equals to AY into WU into LEX. Remember that in both the span moment, here LEX is being multiplied, not the LEY. This is the main key point while calculating the MUX and MUY. Now where from these things are given? These things are calculated from page number 26, page number 90 and page number 91.